Hi, Holly. I'm really sorry it's taken me so long to get back to you. It's been quite a day. Okay, so we're going to go through 5, 6, and 8. So it says the length L of a rectangle is decreasing at a rate of 7 centimeters per second, while the width is increasing at a rate of 7 centimeters per second. When L is 15 and W is 8, find the rates, blah, blah, blah. So this first part says the rate of change of the area. So area equals length times width. So we're going to have to do the product rule. So dA dt, which is what we're looking for. So we'll leave L alone, take the derivative of W, which is dW dt, plus take the derivative of L, which is dL dt W. Okay, so I'm sorry, I don't know what's going on with this thing tonight. Okay, so it says the length is decreasing at a rate of 7. So for dL dt, we're going to plug in a negative 7. And the width is increasing at a rate of 7. So that's 7. When L is 15 and W is 8. Okay, so I'll let you put that into your calculator. I guess you see that it's going to be 49. Okay. Is the area, so since that's positive, it's increasing. Okay, perimeter of the rectangle. So P equals 2L plus 2W. So dP dt equals 2dL dt plus 2dW dt. So your dL dt was a negative 7. The dWt is 7. So we get negative 14 plus 14 is 0 when you plug those in. Okay, and since it's 0, that means it's constant. It's not increasing or decreasing. So then for the last part, for the length of the diagonals, so if we have our length and our width, the diagonal forms a right triangle. So we'd have L squared Okay, I'm sorry if this keeps cutting in and out. My pen is not working very well. It's driving me crazy, so doing the best I can. So here, this forms a right triangle, so we'd have L squared plus W squared equals D squared. So we'd have 2L dL dt plus 2W dW dt equals 2D dd dt. So what we're looking for is dd dt. So you're going to plug in stuff for all of this. Now to find what to plug in for D, you know what L and W are, and then you'll use the Pythagorean theorem to find D, and then you'll plug it in here. Okay. Let's go. Here's number 6. So it says the function s equals f of t gives the position of a body moving on a coordinate line with s in meters and t in seconds. Find the body's speed and acceleration at the end of the interval. So the speed, you're going to take derivative. So it's going to be the absolute value of the derivative at 4, because it says the end of the interval. So our derivative, so ds dt, is equal to negative 3t squared plus 8t minus 4. So you would plug in 4, and speed is always positive, so take absolute value, just make it positive. Okay, and the acceleration, you're going to take the derivative of the derivative, so the second derivative, so negative 6t, oh my gosh, plus 8, and you'll plug in 4 there. For that one, you will not take the absolute value. Okay? Okay, last one. So here's where you had 8, and we want to simplify it. So first, we're going to FOIL these. So we'd have negative cosecant squared of x, negative cosecant squared of x, cotangent of x. So that's the cosecant times the negative cosecant cotangent. Okay, the outside terms would give us, so plus cosecant cubed of x. The inside terms would give us negative cosecant x cotangent squared of x. And the last terms would give us plus cosecant squared x cotangent of x. And then for the second set, we also need to FOIL. So the first terms would give us negative cos, oh my gosh, this pen seriously just keeps cutting in and out. It's like when you have a pen and it runs out of ink. But I just put new batteries in, so I don't know what's going on. Where am I? Okay, negative cosecant squared of x cotangent of x. That's first, so outside would be plus cosecant x cotangent squared of x. The inside terms would be negative cosecant cubed of x, and the last terms would be plus cotangent cubed of x. Okay, and now we want to simplify things. So here we have a negative cosecant cotangent, and here we have a positive one. So those two are going to cancel out. Here we have cosecant cubed and a negative cosecant cubed. Oh, sorry, this last one should not be cotangent cubed. It should be negative cosecant squared of x. That would be positive. Cosecant squared of x, cotangent of x. Okay. So cosecant, cotangent, here we've got that one, and then these cancel out here. So our final answer is 0. They all actually cancel out, which is kind of amazing after that. Okay, so I will see you tomorrow.